This video goes through correcting your quiz for looking for Pythagoras. So please look at each problem that you missed and think about what you need to do differently. The first problem asked us to find the area of the polygon. And some people were trying to find each little piece inside of this triangle. However, what you start to run into is that there's not a lot of right triangles in here, and it becomes kind of difficult to figure out what some of those triangles really are. So a better strategy would be to find the area of the outside and then subtract the pieces that are not included so that you can find the total area. So for example, I can see that this is 4 by 4. So it looks like an area of 16 if it was the full square. And now I can subtract out each piece that's missing. So 1 by 2, and then half of that, because it's a triangle, this would be an area of 2. Over here I have 2 by 3, which would be 6, but because it's a triangle, it's half, or 3. And then 2 by 4, which would give me 8, but half of that as a triangle would give me 4. So 16 minus 2 minus 4 minus 3, which is the same as 16 minus 9, which would give me 7. So my answer should be 7 units. Again, that's the area of this whole triangle inside. For B, you could have done either strategy, subtraction or adding all of the pieces inside. It's kind of up to you. I'll show you the other strategy in terms of using the inside pieces, but again, you could have used either one. So I'm breaking this apart into some right triangles, and I'm going to find the area of each piece. And so you'll notice I'm noticing where the whole squares are, and then I'm noticing where I can make right triangles. So, for example, on the inside here, I have 1, 2, 3, 4, 5, 6, 7, 8 units. Here I have a triangle that's 2 by 1, so 2, but half of that would be an area of 1. This is a 1/2, 1/2. 1 by 2 would give me 2, but it's a triangle, so 1. And 1 by 3, which would give me 3, but it's half of that, 1.5. Another 1 by 3, so another 1.5. And another half. So now I'm going to add all these pieces together. So I have 8 plus 1 plus 1, so plus 2. 1.5 plus 1.5 would give me 3. And then plus 3 halves, so that's 1.5. So 8 plus 2, I'm at 10, plus 3 is 13, plus 1.5 would give me 14.5. So this answer should have been 14.5 units. Again, if you wanted to use the subtraction strategy instead and find the entire area on the outside and then subtract, that would have been just as fine, but you should have had the same answer. For number 2, a square has an area of 64 square centimeters. So what's the exact side length? Well, if you think about a square with an area of 64, one side would be the square root of 64, and I should recognize that's a perfect square, so that will be exactly 8. For number 3, I'm going to select true or false. So here you might have used your calculator or done some different things to kind of figure out these statements. The first one says the square root of 40 is located between point A and point B. And so point A here, I notice it's a little bit before that little hash mark here. And so just kind of noticing the scale here, this is going by tenths. So this would be 6.1, 6.2, 6.3, 6.4, right, 6.5, 6.6, 6.7, 6.8, 6.9, and then 7. So it just might help to label what's there just so you understand what the scale is. So the square root of 40, so when I find the square root of 40, I get a value of 6.3, so around 6 3/10, and it goes on past that, but I'm just going to say it's approximately that. And so I can see that A is a little less than 6 1/10, B is around 6 4/10, so I can see that it would be between those, so that would be true. The value of the square root of 42, when I find the square root of 42, I find it's approximately 6.48, or around 6 5/10 approximately. So would it be to the right of point D? So to the right would be this way here, and I see that D is around maybe 6 8 a little more than 6 8/10, maybe around 6.85, 6 85/100. So I'm noticing that this value is not larger, so it would not be to the right. So this is false. And then finally, the value at point C is less than the square root of 45. Well, the square root of 45 would give me around 6 7/10. And so if I look at C, it looks like it's around 6 and maybe 55/100, so between 6.5 and 6.6. And so it is less than 6 7/10, so I'm going to say that's true. In question 4, I'm going to graph each point on the coordinate grid, and then I'm going to connect them to make a closed figure. So P is at -1, -2. Q is at 2, -4. I connect these together. And R is at 1, 1. So again, I'm going to connect these together best that I can. And now I'm ready to do some other things with this shape. For the next part of the question, I'm going to find the exact length of each side. So I'm going to go ahead and again mark in those values. So I had 1, 1, -1, -2, and 2, -4. And so I'm going to connect those with the straightest lines that I can here. And my next part is to find each side length. So the strategy we've talked about in class is to make squares off of the side lengths. And you can do that by thinking about the slopes. So for example, this line right here, I'm going to think about what the slope is. And I can see in this case it's up 1, 2, 3, and over 2. So that has a slope of 3 over 2. And I want to create a line that's perpendicular to that so I can make my square. So for perpendicular, I do the opposite reciprocal, so -2/3. So if I think about that carefully, that means, right, with -2/3, I'm going to go back 3 and then up 2 to get my slope of -2/3, right? That would give me down 2 over 3. And so I'm going to connect that here to start making my square. And same thing over here, I'm going to go back 1, 2, 3, up 2. Again, that gives me a slope of -2/3. I'm going to connect this here to make my square. And now I can think about what the area is. So it might help to draw some boxes again and think about where my right triangles are. And so here I can see that this side length here is going to be the square root of this square's area. So I have an area of 1. I have a triangle here that's 2 by 3, so that would be 6, but half of that would be 3. So each of these triangles actually is 3. And so that means my total area is 3 times 4, which is 12, plus 1. So this is a total area of 13. And so this square, or this side length right here is the square root of 13. So again, just to remember the letters, this is P, this is Q, and this is R. So the length PR, or RP over here, is the square root of 13. I'm also going to find PQ. So from P to Q, I see that this has a slope of -2 down 2 over 3. So it's kind of related to the one I had before. Now for the perpendicular slope, I'm going to do the opposite reciprocal. So 3 over 2, and now it's positive. So to make that square, I'm going to go down 3 over 2. And this here has a slope of +3 over 2. And then I have another line here, down 3 over 2. Connect these here. And I'm going to go ahead and mark my right triangles again so I can find that area. So I have 1. These triangles are all 2 by 3, so that looks like 6, but it's half because it's a triangle, so 3. And I actually notice that it makes the same square as what I had before. So this has a total area of 13, but again, the side length here is going to be the square root of 13. So length PQ is the square root of 13. All right, we've got one side left to look at, and that would be RQ or QR. So this one here, try to make that line a little bit straighter. Looking at the slope, I see that it goes down 1, 2, 3, 4, 5. So it's going down 5 and over 1. So it's a slope of -5. So again, the opposite reciprocal of that will be positive 1/5. So I'm going to go over 5, 1, 2, 3, 4, 5, up 1. That's part of this square right here. Again, over 5, 1, 2, 3, 4, 5, up 1. So I'm going to go ahead and mark that in. I have my whole square now. And I'm going to go ahead and figure out where my largest possible square is, maybe inside. Here I can see I've got a 4 by 4 or 16 square. And then I have these right triangles on the outside. And it's a little hard to see these right triangles sometimes, but this is 1, 2, 3, 4, 5 by 1. So each of these small triangles is going to be an area of 2.5. Since 5 times 1 is 5, but half of that is 2.5. So each of these small triangles is 2.5. So 2.5 times 4 gives me 10. So that total area is 10 plus 16 or 26. And so this side length is going to be the square root of that area, so the square root of 26. I can't simplify any of these further, so I'm actually going to stop right there. The last thing we're going to do is find the area of the figure. So I'm going to plot these points again really quickly so we can see them and connect them together with as straight of lines as I can. And in case you forgot, the best strategy here is to put a rectangle around this triangle and subtract out the pieces that I don't need. So this entire rectangle is 3 by 5, so it has an area of 15. But I can also find the area of these smaller triangles so I can subtract them out. So for example, this triangle is 1 by 5, which would be 5, but it's half of that, so it's 2.5. So I'm going to subtract out 2.5. Over here I have two triangles that are actually the same size. Both of them are 2 by 3, which is 6, but since it's a triangle, it's 3. So this is an area of 3, and this is also an area of 3. So I'm going to subtract out the 3's also. So I get 15 minus 8.5, and that would give me an area of 6.5. The last skill on your quiz was to simplify each square root, and we noted in class that one helpful strategy is to make a list of some of those roots. So for example, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5. These are some of the factors that you want to be looking for. So for example, with 48, I might know that I can make that by multiplying the square root of 16 by the square root of 3. And so the square root of 16 can be written as 4. The square root of 3 just stays as the square root of 3. So the answer for A is 4 root 3. For B, I'm just going to deal with the square root of 75 right now. I recognize that 25 is a factor of 75. So root 25 times root 3. And I still have that 2 at the front as well that I'm going to deal with too. So root 25 is going to become 5. Root 3 is going to stay the same. And then I also have this 2 coming down. And I'm going to multiply the 2 and the 5 together to get 10. And then I have root 3. Lastly, for root 20, again, I'm going to be looking at these perfect square factors over here, and I'm going to think about how 4 times 5 would make 20. And so again, root 5 times root 4. Root 4 is going to turn into a 2 because the square root of 4 is 2, and then the square root of 5 stays the same. So 2 root 5 would be the answer for C. So the plan is that we're going to have a retake in class on the Looking for Pythagoras quiz on Wednesday. And so I would really take some time to review these skills, make sure you're comfortable finding the lengths of line segments, finding the areas of different shapes like triangles with a grid, finding how to simplify radicals, All of these are really important skills for this unit, and it'll be very important for you to make sure you're clear on what to do. See you tomorrow.